Hello, friends. Welcome to Hashtable Education. And today we are going to start a new series on data structure. In this series, we are going to talk about data structure and interview questions asked for data structure. So, we'll talk about multiple data structure and we'll take some interview questions regarding those data structure and we'll solve those interview questions. We'll write algorithms, we'll write pseudocode for those interview questions and we'll solve it together. So, let's get right into it. So, what is a data structure? Data structure, as the name suggested, is structuring of data. So, for in our programming world, we have to manage our data in such a way that we show that data to our user in much effective way, so that our user is getting the data in a fastest way, right? So anyone who is searching anything on Google, or anyone who is searching anything on your website or in your mobile application, they are expecting their data to be shown to them in as soon as possible. So you have to write your logic, you have to write your logic in such a way on your data so that your user is getting that data in very fast way, right? So data structure is a way of collecting and organizing data in such a way that we can perform operations on these data in effective way. So it means that our website, let's say, let me take an example. Let's say you need to build a website which will be used to book trains, right? So you will have to handle a lot of data related to trains, right? So when a user is searching on your website for a particular train, you have to take that particular train number and search it through all the trains which is available, right? And that you will do using a data structure. So you will store that those number of trains using a data structure, and then you will perform the search operation on that using a data structure. So what I'm trying to say here is, in our programming world, to perform any operation on data, you need to have a proper data structure. You need to use a proper data structure so that you can perform that operation in an effective way, and your user is getting the data in effective way, and they are getting the data in the fastest way. They are, because a happy user is, happy uh, organization. So if you're running an organization, you need a happy customer. So in that way, oh, that's a long shot, but yes. So you need to structure your data in such a way so that you can present that data to your user in the most fastest way so that your user is happy. Okay. So there are multiple data structures, and today in this video we'll be talking about arrays, stack, queues, linked lists, trees, graph, and hash table. So in our interviews, the interviewer will give you a question like find the minimum element in the array, or uh, find create find the duplicate element in a linked list, or find the leaf node in the tree. So multiple type of questions based on these array. Why do they ask these questions? Because in your programming you will be storing, you will be searching, you will be sorting your data, you will be performing multiple operation on your data using these array. In this video we'll be talking about all these data structures, and then we will take some particular questions which will be asked in your interviews, most frequent asked question based on these data structure, and then we'll talk about those questions in the upcoming video. So in each video, in the upcoming videos, we will take one question in one video and we will solve it together, and we'll write pseudocode for those for that particular question. Okay, so I will not be using any programming language in particular. I'll write pseudocode so that you can write the code in any programming language. Okay, so let's talk about our first data structure, that is array. Array is the most widely used data structure. Okay, so in any programming language, if you're writing code, you will be using array a lot, like literally a lot, because you will have to. So what does array mean? Array holds fixed number of items of same data type. So if you want to hold an number of elements which are integer, then you will use array. Or if you want to hold number of element which are string, then you will use a string array. So this is an array. This is an integer array. You can see this is holding some integers, and these are called elements. These are the elements of the array, and we can refer to these elements using these indexes. So these are the index of our array. So if you want to get an array, get an element of from this array at the index of 3, then you will just call the array name and then index of 3, and then you will get this element. Same way you can get any element using these indexes. So this is an array. We'll see some advantages and drawbacks of an array. The advantages of an array, as I said, you can use a single name to access multiple data items of same data type. So in an array, you can store multiple data items of same data type. So you can use multiple integer, multiple strings, and that can be accessed using a single name. Another advantage of an array is implementation of metrics. So you can implement 2D metrics using an array, or you can also implement queues, linked lists, all these data structures using an array. Drawback of array is the fixed size. So as I said, array is always fixed size. So before implementing an array, you should always know that how many numbers of element you need to store in that array. So let's say you are creating an array of 5 element, then you cannot increase the size of an array. It is not dynamic, it is static. Arrays are static data structure. Okay, so in array, every element is stored at a memory location, right? So that is the consecutive memory location. So each element in an array is stored at consecutive memory location. So if you want to add an element at the first index of an array, so if we see this array, in this array, if we want to store an element at first location, then we have to shift all these elements by uh, its next location. We will have to shift these elements. So let's say this element is at the address of 200, then the next element would be at address of 201, and the another next element would be 202. So it is on the consecutive memory location. If you want to store an element at this memory address, then you will have to shift this element to this memory location, and this element will be shifted to this memory location. So this operation is very costly. So that is why insertion and deletion operation is very costly in array because of its fixed size and consecutive memory locations. So these are the drawbacks of array. These arrays are fixed size, it's not dynamic, and insertion and deletion operation could be very difficult. It could be very time consuming and not good for your memory. And also, if you want to add or delete elements from an array, because of its fixed size, it will waste some memory. So let's say if you have an array of 5 elements and you delete 2 elements of those array, or you only store 3 elements in that array, then 2 memory location will be wasted. So these are some of the drawbacks of an array. Okay, some common interview questions asked for array are sorting algorithm, find the second minimum element of an array, and rearrange positive and negative numbers in an array. So we will be talking about multiple sorting algorithm like quick sort, merge sort, and insertion, selection, these there are multiple types of sorting algorithm, and we will look into all those sorting algorithms. I have already created a video on all these sorting algorithms, so I'll probably add those video in this series, or leave a link at the bottom of the in the description section, so you can go through those. So we will not go through sorting algorithms, but as I have written over here, these are very commonly asked interview question when you go for, a technical interview. So if you're going for technical interview and you are expecting data structure questions, so you can expect from your interview the sorting algorithm question. Like, they can give you an array and you will have to sort it using merge sort or quick sort, or any sorting algorithm which you think is suitable. uh, so I have already created some videos. I will leave link for those videos, so you can go ahead and watch those videos. In the coming video, in this series, we will talk about this question: find the second minimum element of an array. And then in the next video, we'll talk about this question: rearrange positive and negative numbers in an array. So by resolving these issues, we will know how to use an array and how to write pseudocode, on those array to make these operations, to resolve these operations. Okay. Uh, the next uh, the next data structure we'll take is stacks. So stack is a LIFO type data structure, last in first out. So as you can see over here, this is a stack of books. So the first in, it would be the first out. So the book you keep first, yeah. So it is last in first out, and first in last out. So the book you keep first would be going out of the queue, going out of the stack in the last, and the book you kept last would be going out of this stack at the first. So the element you keep at the first, at the last, would be coming out of the stack at the first. So as you can see, I'm making it complicated, I guess. So let's say you have number of books and you keep it on top of each other. So I kept first book, and then I kept second book on top of this, and then I kept third book on top of this. So while taking out these books, you will take the first book on the stack, so the one which was inserted in the last, and then you will take the second one, and then you will take the last one. So as it says, LIFO, last in first out. There are multiple operations we can perform on stack, which is push, insert an element at the top of an stack, then pop, return the top element after removing from the stack, then is empty. It returns true if the stack is empty. So yeah, and top returns the top element without removing from the stack. So there's these two sound same, pop and top. Pop will return the top element after removing it from the stack. So if you perform a pop operation on a stack, we will remove this element and give this element to you, right? This book index will be with you. Whereas the top returns the top element without removing it from the stack. So this will not be removed from the stack, but you will get to know that which element is at the top, right? So these two operations are slightly different. So these are the operation you can perform on stack. And yes, so the common interview questions asked on stack are evaluating postfix expression using a stack, sort value in stack, check balanced parenthesis in an expression. So in our upcoming videos, we will be solving these questions. Okay, the next data structure I want to talk about is queues. Queues is opposite of stack. It is first in, first out. So if we keep books like this, the if we keep the first book, uh, like so, yeah. So what do we do? So in our last example, I said you keep the books, first book, and then on top of another book, and then on top of another book. But what you do over here in queues, you keep the first book, and below that you keep the second book, and then below that you keep the third book, right? So the first book you kept would be on top itself, whereas in stack, the first book you kept, on top of that book you were keeping the next books, right? So this is FIFO operation. Perfect example of FIFO operation would be the queues. Let's say you are going for election and you are in a queue. So the person who came first would be going to do the voting at the first, and then they will go out of the queue very first. They will be the first person who will go out of the queue, and the last person who comes into the queue, they will be the last to leave the queue. So the first person who gets into the queue will be the first to leave the queue, and the last person who gets into the queue would be the last to get out of the queue. Okay, so the operations we can perform on queues are in queue inserts element to the end of the queue. So if you want to insert an element at the end of the queue, we'll use enqueue operation. Dequeue removes an element from the start of the queue. So if you want to remove an element from an queue at the first element on the queue, then you will use dequeue. Is empty as stack. Over here also we have is empty, which will return true if queue is empty. And top will return the first element of the queue without removing it from the queue, same as what we saw in stack. So dequeue will remove the first element from the queue and also give you the first element, whereas top will give you the first element, but it wouldn't remove it from the queue. Okay, common interview questions on queue are implementing stack using a queue. So we'll see how we can implement stack using a queue, and then we'll see reversing first k element of a queue, and then we'll see generate binary numbers from 1 to n using a queue. So these are some common interview questions we'll take in upcoming videos of this series. Okay, linked list. So linked list is very important interview, important data structure which will be asked in your interviews a lot. So linked list is a dynamic data structure where number of data is not fixed like an array, and it can grow and shrink based on demand. So if you compare it with array is a static data structure where you cannot grow or shrink your array. If you want to add more elements in an array, that is not possible because it is a static data structure. So whereas linked list is a dynamic data structure in which you can add or delete elements uh, as as per your demand. So each node in a linked list consists of two things. One is data and another is linked to the next node. So as you can see over here, we have a linked list, and these are called a node. This is a node, this is a node, and this is a node. Each node will have data and address of the next node. So this part of this node is holding the data value, and the next part of the node will hold the address of the next node. So each node will consist of data and address to the next node, and then this node has this data and address to the next node. This node has this data and address to the next node. This is a linked list. And then why do we use linked list? Because linked list is good with insertion and deletion. You can insert and delete element in a linked list from the middle of the element, in the middle or at the first, wherever you want. It would be very cost effective because all you have to do is just change this address. So if you add one more element in this linked list, all you have to do is change the address of this linked node to this. You will be just pointing this this uh, so we are each node is having address of the next node, right? So in the address section we'll just replace the address of the new node with this node. So we will see all these operations, how we actually perform the insertion and deletion in the middle of the linked list, or at the first of the linked list, or at the last of the linked list. But as of now, just understand that insertion and deletion is much faster in linked list comparing to an array. And you can insert and delete a linked list just by changing the pointers in the linked list. Whereas linked list is not good when it comes to searching, because you'll have to go through each of these elements. So if you have to search for an element D, you will have to start from first location, and then you will traverse through your linked list until you get an element D. So if you have a linked list of n elements, n nodes, then you will have to traverse through all the nodes to search for one single node, which is not very good. So linked list is good for insertion and deletion, whereas it is not good for search operation. It is totally opposite of an array. Array is good for search operation because you can search for an element using its index, whereas for insertion and deletion, you will have to play with the memory location. You have to shift the memory locations. Shift each element in the memory location. So array is not good for insertion and deletion, whereas linked list is good for insertion and deletion because you just have to change the pointer. Whereas array is good for searching and linked list is not good for searching because you have to traverse through each of the element to search for one single element. The common interview question for linked list are reversing a linked list, detecting loop in the linked list, whether there is a loop in the linked list or not, and then return nth node from the end of the linked list and remove duplicates from a linked list. So we will see all these operations in our upcoming videos. I will show you how to perform these operations on linked list, and it will become more clear to you. Okay, this is wrong. This should be on top. Anyways, so let's continue. It's a tree data structure. As you can see, tree is a hierarchical data structure represented by nodes connected by edges. I'm very sorry about this UI. It should be on top. So I will not stop the video and make it on top because I don't want to stop this flow. Uh, but yes, it is. So now we are talking about tree data structure, and tree data structure is hierarchical data structure represented by nodes connected by edges. So as you can see over here, these are nodes and it is connected by edges. A very good example of tree data structure is your family tree, right? Your grandfather, and then your father, and then your you are the children of the father. So it shows a hierarchy. It shows a family hierarchy. So as you can see, the top the top node in a tree data structure is called root node, and then their child nodes are called child nodes. Okay, so root node will be the parent, and their child node would be child nodes, the left and right node. So these are called child nodes to this root node. Okay, and this would be connected using an edge, and then this is a parent node for these child nodes. So these are child nodes for this parent node, and this is connected using these edges. And the last node in the tree is called leaf node. The most important tree is binary tree. Binary tree means each node will have maximum of two child, so you cannot have third child. So it is very much legit to have three child in a tree data structure. But in most of the interviews, you will be asked about binary tree only. So when we say binary tree, a node should have only maximum of two child nodes. So this node can have only two child nodes, then only it is a binary tree. This tree, in this example, it is a binary tree because each node has two child nodes. Then binary search tree. We will be talking about binary search tree. What it means by each node, the left of each node will be smaller than the root node, and the right of each node would be greater than the root node. So over here, 5 is smaller than 8 and 11 is greater than 8. And then if we go for this node, 3 is smaller than 5 and 4 is also smaller than 5. So this tree is not a binary search tree. If you want to make this tree a binary search tree, you should make it, just change 4 to 6. So if this 4 is 6, then 6 is greater than 5. And over here, 11, 8 is smaller than 11, and 15 is greater than 11. So this part is also binary tree. This part is also binary search tree, whereas this part is breaking the rules of binary search tree. So if you make this 6, then this tree is a binary search tree. So binary search tree, as I said, the left node would be smaller than the root node and right node would be greater than root node. Okay. Common interview question for tree would be finding the height of the binary tree, finding the kth value in the binary search tree, finding nodes at k distance from the root node, and then find ancestors of a given node in the binary tree. So we will resolve all these questions. We'll look into all these questions in our upcoming tree data structure interview questions series video. So in our upcoming videos, we will resolve these questions and we'll write pseudocode for all of these questions. Okay. The next data structure we want to look into is graph. Graph is a set of vertex and edges. So these are vertex and it is connected by edge. So it so we have A, B, C, D. These are the vertex, and these A, B, C, D vertex are connected by these edges. So graph is set of vertex and edges, and graph could be bidirectional or monodirectional. So over here we have not shown any direction, so it is a monodirectional graph. Okay, if you show a direction from A to B, like direction, then it would be a sorry, it is no. So because we don't have any direction, it is a simple graph, but we can create uh, a, a graph which has directions. Okay, I said it wrong. So because it doesn't have any direction, it is a bidirectional. So you can have A to B or B to A both. When when it has a direction like A to B and there is a arrow like this, then it says A to B only. So you can use bidirectional and monodirectional graph as well. So where to use bidirectional and monodirectional? A very good example of graph data structure is Facebook and Twitter. So Facebook is an example of bidirectional graph where each connection represents friendship between people. So let's say people are vertexes. So this is your friend and this is you. So you both are connected with each other because you sent a friend request to your friend and he accepted it. So you both are connected using a bidirectional edge in our graph. Whereas Twitter is an example of monodirectional graph because one person can follow another without another person following him or her. So let's say you can follow Ellen DeGeneres, but she doesn't have to follow you because she doesn't know you, so she doesn't have to follow you unless you are a big star as well. So that would be a bidirectional because you are following Ellen. So there will be a direction from you to Ellen, but there will not be a direction from Ellen to you because you are not following each other. Only you are following Ellen. So this is a monodirectional. I'm sorry, I'm messed up with these terminologies, but monodirectional means you both are following each other, and bidirectional means only one. Oh, again I missed it. Bidirectional means you both are following each other, and monodirectional means one person is following another person, and the another person is not following back the first person. So Facebook is a bidirectional example of our graph data structure, whereas Twitter is monodirectional example of our graph data structure. So the common interview questions asked for graph are implement depth and breadth first search. So we can perform a search operation on graph using depth first and breadth first search. So we will look into these in deeply, I will create two different videos for BFS and DFS. In short form, we call it BFS and DFS. So I'll make two different videos of BFS and DFS, and we'll look more deeply into that, and we'll write pseudocode for each of these operations. And then check if a graph is a tree or not. So a graph can be a tree. So we will write an algorithm, a pseudocode to see if the graph is tree or not, and then count the number of edges in a graph and find shortest path between two vertices. So we'll look into all these questions in our upcoming videos in this series. Okay, hash table. Another very good data structure which you will be using a lot in your programming is hash table. A hash table uses a hash function to compute an index into an array of buckets or slots from which the desired value can be found. So hash table is a key value type of data structure where you can store your value for a key, and this location can be found using a hash function. So to perform a search operation, all you have to do is call your hash function for a particular key value for particular location, and then it will give you the location of that particular element in the hash table. So search operation is very extremely fast with hash table due to a hash function. So this is a hash table with key value pairs, and these are the indexes of this hash table. You can compute the location of any of this element using a hash function. So hash tables are generally implemented using an array. Okay. Commonly asked interview question for hash table are finding symmetric pairs in an array, trace complete path of a journey, find if an array is a subset of another array, and check if given arrays are disjoint. So we will look into these questions in our upcoming series, as I have been telling for all these interview questions. So this was a brief introduction to all the data structure and all the questions we'll be taking in our upcoming series. We will talk about this question. I'll explain you more that what this question means, and then we will solve it together. We'll write the pseudocode together so that we are more confident when we are in our interview, and we can crack those interviews. Thank you so much for watching this video. In the upcoming video, we will talk about these data structure in more details. So if you so I would suggest you to um, subscribe and comment if you like this video. Thank you so much.